can't get that game anymore. It's like Greek.
What game are you talking about?
Wow.
I kind of figured as much.
I think I'm gonna get sucked back into ours now.
World of Warcraft expansion 12.
All right, how's it going?
Pretty good.
Going okay, good.
It's sunny.
The weather's getting nice out, so coding gets harder.
It's always Washington.
This is true, yeah. So I realized that in my zeal to start talking about swing classes on Monday, I completely forgot to talk about PA1. And I definitely wanted to mention PA1, so obviously that's been graded by now, and your grades are on Canvas, and I tried to put comments, especially for deductions. But I wanted to make some general comments on PA1. The first one is that I'm absolutely thrilled with what people turned in. Okay, by and large, most of the submissions worked perfectly, with the possible exception of dealing with division by zero, right? Which is a tricky case, and it's not tricky like you need a PhD to be able to figure it out, right? It's tricky in that there's lots of little edge cases to deal with. And if your denominator of zero was tripping up your code, it's not an indication of like, a fundamental, you got to go back to CSE 120 or something, right? It's just details, right? And there's always maddening details in different programs that we deal with. But what I was mostly struck by was you're doing object-oriented coding now, right? The idea of creating a class and constructing these objects and picking up fields from the objects and calling the methods, nobody seemed to have trouble with that in the end, right? The submissions that I saw, everybody was doing that perfectly, which is fantastic, because it means we can use this language of object-oriented design, and we can use these mechanisms, and we can start continuing to build more complex programs, PA2 in particular, and then we can start really having fun with them with PA3 and onward from there. So I think people are in really good shape, which is like awesome. Okay, so congratulate yourselves on PA1 performance. And if there's details that you're not sure about, we can definitely talk about those. So I wanted to go through briefly some code for PA1. I just gotta find it. So here's an older version of this class with a shocking lack of comments. So I did this to show you what it looks like without comments. No,
But it's so obvious.
it's so obvious, right? So I wrote a new version of this for this quarter, and it was much nicer than this, but I have no idea where I put it. So we're looking at an older version which has some inefficiencies in it. But anyway, basic setup, right? So it's a class called fraction. At least the two pieces of information you need are the numerator and the denominator. A lot of people chose to put a flag in to indicate whether the fraction was undefined. That's probably a better way to do it than what I did, which was just to keep checking the denominator to see if it's zero. Flag makes a lot more sense. But I didn't use a flag here. So the constructor does a fair amount of conditioning on your fraction, and you didn't have to do this. You can condition when you're using the fraction, but if you condition your fraction right in the very beginning, you never have to think about it again. So what are we doing in the constructor? We save the numerator and the denominator. That's the first thing. And then if the denominator is negative, I just reverse the sign on both the top and the bottom. Okay, I multiply by -1 over -1. That guarantees me my denominator is never negative. Could be zero, could be positive. Okay, I did not need to do this. I don't know why I did it. But if the denominator is 0, I force the numerator to 1. But I never use that fact anywhere. But it just feels better to know that my illegal numbers are always 1 over 0. Okay, if the numerator is 0, I force the denominator to 1. because a fraction like this is still 0. And when I'm converting things to a string, if I have a fraction 0 over 5, I want to just return that as opposed to 0/5. And if I force 0 over 5 to look like 0 over 1, I know that if I ever have a fraction a over 1, I'm going to print it as just an a, and it saves me from dealing with this as a special case. But not strictly necessary. So I normalize the numerator if the number is equal to 0 down here, and then I just go ahead and reduce it. So reduce is the whole Euclid's algorithm, find the greatest common factor and divide the numerator and denominator by that factor. Put everything in lowest form. So when I come out of my constructor, I've got all these assumptions I can make about my fraction, and they're always going to be true. And as long as every time I make a fraction, I go through the constructor, which I have to do, right, those assumptions will hold for every fraction that I deal with. All right, so if you construct with just an integer, I set the numerator to whatever integer you want, and the denominator to 1. That's kind of a slam dunk, right? And there's no possibility of division by 0, negative denominators, etc., etc. All right, so my two-string method becomes 2 lines, basically. If the denominator is 0, it's not a number. It's undefined. It's illegal. I just return nan. And I'm going to do this again and again and again in my code. Anytime I'm working with a fraction, first thing I'm going to do is check the denominator. If it's 0, it's undefined. Okay, so I return right away, and I return the string nan. Otherwise, I return the numerator, and then I just did a ternary operator here. So if the denominator is 1, I just return the numerator. If the denominator is not 1, then I'm going to return the numerator plus a slash plus the denominator. So you can do that with an if statement if you want, but that's a shorter way to do it. So that's the whole two-string. Okay, a pair of accessors for retrieving the numerator and denominator. A horrible implementation of Euclid's algorithm. This is about the longest that I can imagine making it, and almost everybody had a much shorter version. So some people did this recursively, right? In Euclid's algorithm, you can write it recursively. That's really how the algorithm works. You have two numbers, you want the greatest common divisor. You find a smaller pair of numbers and find a GCD of that pair, and you end up with a GCD of the original pair. So it really cries out recursion, but I was in a wordy mood when I wrote this, I guess. So if the denominator is 0, it's an undefined number, I don't have to do anything. Okay, so I just return. If the numerator is negative, I negate it, right? But I have this temporary copy of n and d that I'm using. So I negate it, so I'm only working with positives. And then I do something I didn't have to do. I swap the numerator and denominator so that the numerator is bigger than the denominator. It's not necessary. The algorithm will work either way. And then the loop that we talked about in class, right? Loop until the remainder is 0. Divide the numerator by denominator. Look at the remainder and keep, following the arrows. Moving on to the next thing. And when you're done, d is the greatest common factor. So I just divide both the numerator and denominator by that. And this takes care of positives and negatives for you automatically. Right? If my numerator was originally negative, I'm going to take that and divide by my positive GCD. I'll still end up with a negative. And same with the denominator. And then the arithmetic. And again, the very first thing I do in any of these is look for an undefined number. So if my denominator is 0, or if the argument's denominator is 0, one of those numbers is undefined, and the rules say if you operate with an undefined, you end up with an undefined. So I just return an undefined number, which is 1 over 0. Otherwise, do the cross multiplication. Right, get the numerator of the argument, multiply by our denominator, get the denominator of the argument, multiply by our numerator. That's the new numerator, so all of this. And then multiply the denominators, that's the new denominator. and then pass all of that to the constructor for a fraction, and then return that new fraction. And exactly the same thing for subtraction, multiplication, and division. And then 2 double, again, if the number's illegal, return double dot and it's an undefined number. Otherwise, I converted numerator and denominator to doubles, divided, and returned the result. So that is one implementation of a fraction class. And here's some code I used to test your class. So I made a few fractions in the beginning, printed them out. So 1/2, 2, and 2/3. And then I started operating on them, so multiplying them. Multiplied 2 by 1/2, multiplied 1/2 by 2. Both of those should end up with 1, which should just print as a 1. Did some division, some other additions, played around with some negatives, played around with some zeros, so subtract C from itself, you should get 0. Right, so these are all just kind of tickling the edge cases. And then did some more work with zeros, so set Z equal to 0, printed that out, multiplied by A, multiplied A by 0, all of those should come back with 0. And then started playing with combining operations. So I made a fraction that's basically equal to 1/4, but it's -3 over -12. Added it to itself 4 times, that should give me 1. And then added it to itself 5 times, that should give me 5/4. And then finally just played around with some illegal numbers. So 1 over 0, 0 over 0, a negative over 0, and then a big positive over 0, and those should all be undefined. And so I printed them out, and then I converted them each to double, and then I operated on them with various things, and in all cases, those should give me nans when I convert to strings in the print line. So one of the few cases where I saw people get into trouble with the actual arithmetic operations was sometimes people were using the argument as a temporary variable. So in the add routine, for example, or in multiply, right? They'd take f dot num and they'd set it equal to f dot get num times num. And then they do, set f dot denominator equal to this, and then they return f. And that works great if f is just a local copy of the argument, but it's not. Okay, it's still passed by value in some sense, but remember f is a reference to a fraction. So if we change f dot num, that's going to change the value of f everywhere. And so what I found was in some cases I'd multiply a by b, but then b would end up with a different value afterwards. And so that was throwing up some of the tests. So if you do something like this, that should not change a, and it should not change b. Right? All you're doing is taking this fraction, multiplying by this fraction, and returning what that new fraction is. So c will change, but a and b should be unharmed. All right. So good job on PA1. Looking forward to PA2. Any questions? Yeah.
I was just wondering, so I was trying PA2, and is there how would you make it with the sentinel node? Like, what's the example? Would you just use new node?
Yeah, so probably in your constructor, you would do something like, so here's your MyList class. So you have a variable in your class that you might call sentinel, right? And then in your constructor, you go ahead and say sentinel equals new node. whatever magic value you want to put in there if you're passing a value to your constructor. And now we have an empty list, right? Maybe if you don't do this in your constructor, set your next field to null. And now you got an empty list, which means there's a single node, which is a sentinel node. And then you just need to remember it's there when you start dealing with your list. Make sure you don't use the data from the sentinel node. The reason I say it's not as necessary or useful in Java is because we're not returning the list with a pointer, right? Where sometimes the pointer is null and sometimes the pointer is something else. We're returning, when you construct a MyList, you're returning an object which is a MyList. And that can hold a variable that refers to the first node, and that could be null, and later it could be changed to something not null. It doesn't change the fact that we actually have an object called a MyList, right? And that doesn't have to be null to represent an empty list. The field inside it that we call root, or first node, that can be null, and we can change it later on, and that's all fine, and we never have to change this MyList object. Whereas in C, if we didn't have a sentinel node, then MyList would actually be null. And when you insert something into an empty list, now MyList needs to point to something other than null. So we need to return a pointer to a node from the insert routine, and it just makes things kind of awkward. So that's one place where the sentinel helps.
But that's not actually a pointer, it's, you set it to point to.
So in my main program, I'm going to do something like MyList. I don't know. Right? And even if I don't have a sentinel node, and I don't have any nodes in my list yet, cool is not null. Right? Cool is referring to a MyList. But if I were to look at cool dot first node, right, that might be null. But if I say something like cool dot insert to add a number to the list, well, inside the cool method called insert, I have access to this first node variable. And I can say, is that null? Okay, make a new node equal to 17, set first node equal to that. Or if I delete the first and only node from a list, I'm inside my cool object, right, my MyList class. I can go ahead and say, okay, set first node equal to null to mark an empty list. I don't have to pass it back to a main program in some way, because this thing itself is not changing. It's the contents of this object that's changing, its state, if you will. Did you start to put your hand up?
Yeah, I was thinking like, the constructor was like in place of an init routine in C, right?
Wait, say again?
That the constructor would be like in place of an initialized routine.
Yes, yes, exactly. And we don't have to do that. We could have a totally empty constructor, and we could force you to say something like, you know, cool dot init, and that would create a sentinel node, and it would set the next field to null, and so on and so forth. And that's nothing wrong with that, right? But generally, if you're going to make a list, you're going to want it to be initialized, so you could just do it in the constructor, save a step. But you might have, you know, a reinit, which is an easy way to blow away everything that's in your list. Just set the first node to null, or, you know, set the sentinel to point to null. If you got that, and now you can like reinitialize your list. Yeah.
So the LEP yesterday,
Yeah.
I had the same thing happen to where it wouldn't let me assess it. It kept doing 0 out of 10, and so I did the PSFU thing,
Mm-hmm.
and it said that a VI was running,
That's okay.
and but I killed it, and then it assessed 10 out of 10. And but there was no VI run, like I didn't have any window with VI running.
Did you save the output of all of that?
No.
Ah, okay.
Yes.
But I just don't know why it keeps happening every other
Well, that's what I want to figure out, right? So
Yeah.
It just happened to me.
It must be because no one else is saying, "Hey, me too."
Hey, me too. Yeah, if you can drag the mouse over that whole session, right, and throw it in an email or throw it in a file or something, so that we can go back and look at it. There may be
I mean, at least I
some.
know how to fix it now, so.
Well,
I'm not
yeah,
worried about
but
it.
if
I
it
mean,
does
I'll
happen
still
again,
do
do
it.
that. Yeah,
I will.
definitely.
Well, I'm just saying I'm not as afraid of it
Right,
as I
right.
was the first ODP where it
Yeah.
was assessing 0.
But I definitely want to figure out like if this is an assess issue or if it's a pilot error or what.
Yeah.
Well, I had that issue with I left that note in my PA1 about the issue I had where when I took it off the server it worked, and so I don't know.
Yeah.
And you mentioned doing that same thing, like next time I run into an issue, don't just
Right,
go
right.
through it, try to actually capture it.
Yeah, that would be helpful. Definitely. We do occasionally encounter flakiness in computers, especially when I run Eclipse on Linux right now. But usually it's not the rule, right? And certainly Java from a command line, that should not be happening. And so far, this is the first flakiness that I've heard of with the assessment. Doesn't mean there's not a problem with it. I mean, there very well could be. But I'd like to figure out exactly what that problem is. So we'll keep hammering it.
That's good.
I don't know why killing VI would
I
fix
know,
it
it
though.
was my main if that matters, but.
Okay. All right, anything else? All right. So I went ahead and I did the official install of Eclipse for Linux, and I got a 6-year-old version of Eclipse that didn't work. So I'm back to the version I had, and I went ahead and did some updates, and it still hangs once in a while. So we'll see how bad this gets. I've actually been toying with the idea of also doing IntelliJ in this class, partially because more and more people are using IntelliJ, and Android Studio I think is built on top of it. And I want you to have Eclipse exposure because it's still used a lot in industry, but having exposure to multiple GUIs might not be a bad thing. So we may swing over to IntelliJ at some point. I don't know. We'll see. But we're going to stick with Eclipse for now. So we were doing swing things. So I'm going to start a totally new project. So I'll just call this B class 1. I forgot my mouse in the A section. It was horrifying. Watching me use a trackpad for an hour, I was like in tears.
Guess you didn't have to use one of the ball mouse.
I could do better on it with anything that I could, like,
Even
yeah.
ball mouse?
Yeah.
Ball mouse is driving me
Touchpads used to be great, and they broke it when they started trying to mimic iPhones and give you like multi-finger gestures. And now if you just want to use the trackpad to move the mouse, for me, it doesn't work. It's like all jittery and yeah.
Apple owned like all the gestures you could ever make.
Yeah. So they got a shortcut to like turn mine off now. It's like no more touchpad. All right, so let's make a class. So remember, for Swing, we're going to go into Other. We're going to come down to Window Builder, Swing Designer. Usually we're going to make a JFrame. Okay, that's generally going to be our main class. And I'm just going to call this Bubbles, just so it's got a different name.
super class.
Yeah. So I've got a class named Bubbles. And if I run this, remember, it actually pops up a frame that we can move and we can resize and we can make really big and demaximize and we can close. Bless you. And if you look in the code, this is where my frame is constructed. Okay, so it's called frame, but it's a object of type bubbles. Here's my call to the constructor, new bubbles. And this object, I call the setVisible method and set that equal to true. Now, if I don't call setVisible and I run this, I don't get to see my frame, right? It created it. At least we have faith that it did. But we can't see it and we can't interact with it because we didn't turn on the visibility. So the set visible method is important, right? So that makes it appear. But this is the class bubbles, right? This file right here, from line 8 down to line 41, that's my whole class definition. Is there anything in here where I wrote code called set visible? Did I create or have created for me that method anywhere? Absolutely not. There's a main program, and there's a constructor, and that's it. There's no set visible method. But yet we can say set visible, and we're not getting a syntax error saying undefined method. Right? And if I were to try to call set visible with a lowercase v, it'll certainly tell me that there's no method set visible. So why do we have a set visible method when we didn't write it? We kind of imported it. So there's this keyword extends that we haven't really talked about. And we touched extensions briefly when we were doing rectangles. Public class bubbles, that's the declaration of a class, right? But there's this new stuff on the end. It says extends JFrame. So there's an idea of hierarchy here. So there is a class called a JFrame, and when we say extends, here's our new class bubbles. Here's what's happening. Everything that you find in a JFrame, you now find in this class bubbles. It inherits every function, every variable that JFrame has. And we've seen this before, right? Remember when we made our rectangle class, I mentioned that's an extension of an object, which means everything that's in an object is also in a rectangle. Well, there's one thing in an object in particular called toString, which means that if I have a rectangle, I can say r.toString, and it won't crash. It knows how to get to that method. That is a method of the rectangle class, but it's not a method I wrote in here. It's a method that it inherited from the object class. Now I also have the option in my class definition of rect to write my own toString. And if I do that, when I say r.toString, it's going to call whatever method I created. But if I don't create that method, it's going to use the one that it came from here. So in here, if I say bubbles frame equals new, etc., and then I say frame dot set visible, I didn't write a set visible method in the bubbles class declaration, but there is a set visible method in the JFrame. That's the code that it's executing.
So when you write your own toString method, will that call overloading?
That's overloading, yeah. I think they might call it overriding. Overloading I've heard used more for like operator symbols, but it's just exactly the same concept. So let's take another look at a JFrame. So here's a JFrame, and if we find set visible, it shows up down here. It's actually a method that's inherited from the window class. So if we look up here, remember a JFrame is a frame and a frame is a window, and the window class contains a set visible, which means that a frame class also contains it and the JFrame class contains it, which means our bubbles class contains it. But if we actually go down here and we click through on this, right, we get to the set visible method of a window class, and we can read all about it. But that's the documentation for a window. which is a container, component, object. If we look at object again, remember this has, for example, a toString method. But this means that when we made our rectangle class, it also had a wait method, and a notify all method, and a hash code method, and a finalize, and a clone, and all of these. And an equals method, which you can use to tell if two objects are the same. All right. So we're extending a JFrame. We'll play with extensions later. We'll actually make our own class extensions of other classes. And there's details in there that we'll get into another time. But for now, just keep in mind that we're extending an existing class, which means that even though we're only writing a few pieces of code, a few methods, we've got a huge swath of methods available to us. Okay, and we're generally going to take advantage of those.
Is extending Java's version of inheritance?
Yeah, so, and there's subclass and superclass, and the terminology gets a little wonky. JFrame's considered the superclass, even though Bubbles is in some sense extending it. So that terminology is confusing to me. But we'll have to use it because if we want to get to something in the JFrame, we can use a super keyword. So, yeah. We'll play with that later today or next week. All right, so we're going to go into the design window. So remember our basic setup, right? Here's our JFrame. That's the only thing we've created so far. If I click on this, it shows me this is coming from class JFrame. It's got a name, which was, I should have a name. Where's your name? I don't know where your name is. Okay, doesn't have a name. So that's a JFrame. If I click in here, I get this slightly smaller rectangle that's being highlighted by a border now, and that's actually a JPanel. Okay, which is component, container, component, object. And the name of that is content pane. And over here in the source code, this is where it constructs the content pane. So it says content pane equals a new JPanel. It sets the border, it sets the layout manager for it, and then it adds that to the JFrame. Okay, so the JFrame has a set content pane method, and by passing it a content pane, a JPanel, it makes that a thing that's inside the JFrame. So let me call this something else. What should we call our content pane? Jim, okay. We'll make it California Jim. There we go. All right, so I just want something that makes the code a little less
Oh my god, it's gonna be so much fun.
looking all the same. Say what?
It's gonna be so much fun typing that out.
Oh yeah, yeah. Right? So Jim is the name of the JPanel, right? We set its border, we set its layout, and then we add that to the JFrame by saying set content pane. Remember, all of this is inside basically a JFrame class, except it's bubbles, right? All right, and we can play with all the stuff. We can set the background color, we can set a variety of borders and so on. So normally when we run this, you just see a window here, right? It's not clear that there's actually a content pane sitting inside, and that's kind of by design, but we can tweak the border of this thing. So you can type in here, or you can hit on the ... next to it. This is usually what crashes my machine. And we can pick a different border type, so we can add a beveled border. And now we've got a bit of texturing on this content pane. So if I run this, it's not glaringly obvious, but there's a bit of a border there. All right, so let's talk about layout managers. So I mentioned the absolute layout manager on Monday, right? You drag an absolute layout manager into here, and then whenever you drop a component, that's where the component sits. And if you resize the window, your components don't move, right? So I can do an absolute layout. I can drop a button here. I can drop another button here. And when I run, that's where my 2 buttons are. And if I make my window different sizes, the buttons stay in those positions. And if I happen to make my window too small, I cover up my buttons, right? And it doesn't matter. Absolute layout is saying I'm placing this position, this component in a particular position, XY coordinates, okay, relative to the upper left corner of the frame.
So if you ran this on a computer with a small screen, is there a potential since you see?
Yeah, your buttons might not be visible,
Okay.
which is kind of a drag, right? So that's usually not what we're going to do. But for what we're doing in here, right, Absolute Layout Manager is probably the quickest way to get on the air. And if you pick a reasonable size and you're on your own machine, right, it's going to work great. But if you want to be a little more flexible, there's all these other layout managers, okay, flow, grids, borders, grid bags, box layouts, forms, and so on. The only one I want to mention here is Spring, because Spring is pretty straightforward, although I crashed my machine, so I'm not going to fret over it. I'm just going to do a quick restart. Or a slow restart. Oh, I'm really crashed. Okay, we'll just kill it. Okay, gonna delete my buttons. It's not gonna crash. Bless you. Gonna do a spring layout, drop this in here. Now if I take a button and I place it, I get these little blue lines. Those are anchors basically. So it's being anchored to, in this case, the top and the left side of my frame. And let me just show you how this can work. Let me pop one down here at the bottom. And let me put a text area over here, which just disappeared. Wow. Okay. Not having a good day here. Okay. Anyway, so this button, which cooperated, is like anchored to the bottom of the frame. So if I resize the window, right, its positions are relative to that. Let me just throw another button over here since something else is going on. Wow. All right, I got issues here.
The right side is just
Yeah.
not letting newcomers in. It's
So here's the other thing, and I don't know if you can see this on here, but at the top of that button there's a pair of arrows. There's an arrow pointing up and an arrow pointing to the left. Okay, so that's saying what this should be anchored to. So theoretically, and this is knowingly flaky, I can change this and say set right alignment, and it should be anchored to the right side now. And so if I run this, right, that first button now moves as the window grows or shrinks. Yeah, you can definitely, you can make a really cheap video game out of this, like collision. There we go. I gotta call Valve and get that on their site. All right, so you can lose yourself in layout managers, right? And I've used Spring for some things where I wanted a resizable window, but in general I use Absolute. and it'll probably work fine for this class, although if you want to get fancier, try the spring layout, but there's some other ones too. Border does a north, south, west, east, center, and that seems to be the default that it takes, so everything's pegged on one side or the other, or right in the middle. So let me get out of here, and we'll live dangerously. But I am going to go back to an absolute layout. All right, so let's look at code. So what are the things we can place in our containers? So there's labels, which are really just a way to store some text. So this is a label. And I'll make it big enough to store all the characters. And you don't get to interact with that when your code is running. It's really just a way to display some message. So you can use this to label buttons or pieces of your display or whatever. You can change the label from the code, but you can't, click on it or interact with it usually. It's just an output mechanism, so it's a way to convey some information. A text field, a JText field, is this kind of box over here. You can type in that, and you can display text, you can read text, you can respond to events, and so on and so forth. A J button is usually just something that you click, and it fires some code. So it's a push button. Click it and the action happens, click it and the action happens. A toggled button is a little different. So a regular button you just click and it's an event. A toggle button, you click and it's pressed, you click again and it's released. Okay, so you can cause code to fire in response to that, and you can read the state of it. I don't know what this is saying because my window's too small. Text pane is a larger area that you can put text into. So we can, not that kind of pane.
Yours is too small, and my font's way too large.
Oh, really?
Look at this. I don't know.
Whoa.
How do you change that?
So you can change any of these things by looking at the properties. So here's a label, for example. I can come over here to the properties. I can change the name of the label. I can change its dimensions. I can change the background color. The font is down here, so right now it's 12 point. So I can crash my Eclipse. But if you click on that ... next to font, it should let you.
Okay, but do you see how even the window is huge? Like the minimized maximum.
Yeah, that's interesting. What's the resolution on your display? Because I'm like 1920 by 1280, so it might be artificially small here.
2736 by 1824.
Whoa, I'm jealous.
Recommended.
Wow.
Maybe there should be a scaling issue.
Yeah, do you have scaling turned on?
Don't even know.
It's like 25, I think it's-
So there's a bigger label. So yeah, you can change all these things over here.
Or this one. Holy mother. Oh yeah, it did something.
So there's a text pane, and let me see if we can do anything with that. So I can type in here. I can copy and cut, and I can paste, and so on. But it's somewhat limited, right? But because I have scroll bars, I can add a scroll bar into this pane, and suddenly I'll have a scrolling pane. Okay, so you can put these things together and expand their behavior. Yeah.
So I noticed in the little demo of the display you have there,
Mm-hmm.
the top bar doesn't look like what pops up. So what dictates whether it adopts like your operating system's?
What top part doesn't look like? Oh,
Like-
that?
Yeah, so like
Yeah.
when you run it, it looks like what the rest of your windows would look like.
Yeah. Right, I got a blue thing and I got circles around my buttons. So in Linux, right, you can choose how you want Windows to render, and I've just got a package that says do that style, and that takes precedence. And I don't know if there's a way to force that. I'm guessing there probably is, though.
So that's not really an Eclipse thing?
That's not an Eclipse thing, yeah, that's an operating system thing.
Okay.
Yeah, I hadn't even noticed that this is like the generic. All right, so what else have we got? Radio buttons. So what are radio buttons?
Multiple choice bubbles.
Multiple choice bubbles, right? And you press one and it deselects the others, right? Do you know why they're called radio buttons?
They communicate with
That's how they worked on the radio.
That's how they worked on old car radios, right? So they were mechanical buttons for selecting the station. When you pressed one, the one that was pressed before would like unpress. And it was a really cool mechanism. I took one apart, I never got it back together again. So they're still called radio buttons. So we need more space here. Yeah, it is. We don't need all of this stuff. We don't need all of this stuff. We could maximize this, but that's no fun. So let's put some radio buttons. So there's a button, and there's a button, and there's a button. Unfortunately, when you run this, they're not acting like radio buttons. Right, I can select them all or none. Multiple choice.
Did you have to link them together?
So you have to link them together, right, exactly. So if I right click on this, there's an option for setting a button group. So I'm just going to say make a new standard button group. And then on this one, I'm going to say set button group, and it's going to be this one that was just created, button group. And I'll do the same thing here. Put that in button group. And now those three will be part of one radio dial. So they do the right thing. All right, so you got radio buttons, we got a checkbox, we got a text area. You can make a password field, so you type in it and you get the little dots, so people can't see your letters, but they can tell how many words are in your password, which is ridiculous. Let's throw a J spinner out here. So a J spinner is just a way to change a value by clicking. Progress bar, scroll bar, sliders, stuff like that. Okay, so this is a good smattering of components. So let's do a 5-minute break, and then we'll come back and we'll throw some code on these, and we'll start looking at properties, and we'll get some practice with using these components.